64 people joined and a few more joining. I never expected to be hosting this workshop for so many people. I expected maybe like a handful of people interested in it, but I'm super excited about the turn up and a little bit nervous as well, but I'm hoping to make the most out of it. So the motivation, right, for setting this workshop was my personal experience in that when what I found that how practice differs from when you're studying these topics. Often I find that when you're learning about this, studying it, the problems are very well structured, they're clear. The constraints you have in your model in your problem formulation are usually given or very clear, easy to define. Your objective is never challenged. It's the right thing to optimize for. And often in academia and textbook, a lot of focus goes on the algorithms, like which algorithm is better, like how do they work, what's the implementation details. And especially like in research papers, if you, for example, read about, in this case, the VRP, you'll find that a lot of I don't know what percentage, but more than half in my experience focus on an algorithm that solves these problems set better than non-algorithms by some percentage. There's a lot of focus on that, but the real world is different. And I wanted to be able to share this idea I have with like a broader audience, is because the real world is like messy. Often in the real world, you don't really know whether a request is a constraint or an objective. It could be either or, and it's up to you to decide. You may have a stakeholder that expresses preferences. These are not a yes or no binary questions. Like, yeah, they prefer that, but does not mean they won't accept a solution that violates that preference. How do you model that? You may not have the right data. You may want to express something, but you don't have it. Like, how do you approximate that? And a big difference between practice and theory is that we don't really care about the best solution most of the time. Good enough is great. We want a solution that works, and well, like how good it is less important, you know? Um, so how did I structure this workshop? I'll first do introductions, introduce myself a little bit, and then go about like the problems that we'll be discussing today, um, how it's in theory and how it's in practice, tell you a little bit more about the workshop goals, what I'm hoping to achieve here, and how I've set this up. If everything went right, you should have received an email with like a few tasks and a repository you could work with, you could clone and work with. I'll tell you how I set it up and what my motivation was, and I'll give you a short demo of how you can use that to implement these kind of requests as yeah, I've formulated. And then we go into like the workshop part of the presentation where I'm going to give you two tasks, which I've already shared, and you're going to be split up in breakout rooms in groups of four, I'm hoping, and you can share your approach if you have done your homework. If you haven't, you can share your ideas and discuss the pros, cons, and the trade-offs you're making with those ideas. Then we'll reconvene and share it to the wider audience, I'm hoping. We'll do that twice. I have like a third task, which I don't think we'll have time for, but I can give it to you as a real problem you may face if you work on this. And we close up with key learnings. I'll have some reflection questions for you and some time in the end where you can ask me anything. In the meantime, if you have questions about it, I won't be able to keep up with the chat, but we have two moderators. They can help. They can pause me and or you feel free to pause me as well if you have a question, and I'll try my best to answer it. So, who am I? My name is Kerem. I am from the Netherlands, born and raised in Amsterdam. You may notice my name is not Dutch. I'm Turkish, ethnically speaking. And how did I start my career? About 10 years ago, I started working at KLM, Royal Dutch Airlines, working on scheduling problems. So that was my first array into this vast field of OR. In 2018, I moved to Singapore. I've lived and worked there for almost 4 years, and I kind of worked on the Vilkratic problem primarily over there, both B2B and B2C. And for the last 3 years, moved back to the Netherlands since 2022, and I've been working on inventory management problems. So like logistics is my thing. I really love it, and there's always more to learn. If you were to ask me what's my favorite algorithm, which may be a fun question or maybe not, I don't know, but is the group of algorithms that are meta heuristics, which is something I've always employed to solve these type of problems. I find they're really fun because they're fast. Uh, they may not be mathematically optimal, but they can produce good solutions quickly. They can scale really well to small problems, large problems. There's fun ways to tweak them and make them work for a problem. They can handle things like nonlinearity really well. Um, So yeah, when I was crafting this, I was hoping everyone can take 30 seconds and introduce themselves, but that's not going to work with 80 or so, maybe 100 people. So what I want you to do is, if you feel free to like introduce yourself in the chat, at least people in watching this can also know who else is watching this, and tell me more about like what your experiences with the VRP and or in general, and what brings you here today. And while you do that, I'll just continue. So the VRP, right? I chose this because I have experience with this, but I also like really love this problem because it's so intuitive, yet so complex to solve. Uh, Often is like defined as follows. You have a set of deliveries or orders you want to perform, and you want to do this in the most efficient way, which is expressed as minimize the number of vehicles used as a primary objective, and a secondary objective, minimize the total distance. But in real world scenarios, there's additional complexities often involved, and this leads to various flavors of this textbook problem. For example, a very common one is the one with time windows, where you need to perform a delivery between a certain time. For example, between 12 and 1 or 3 and 5. Another flavor of this is the pickup and delivery problem, where to perform the delivery, you may first have to pick it up elsewhere. Like a simple example of that would be like Uber Eats, they need to be collected by the restaurant before it's delivered to you, and they can bundle these orders and maybe deliver them sequentially, for example. Another common flavor is the multi-depot VRP, where you don't have a single depot where the vehicles depart from and return to, but multiple, and the challenge becomes like which vehicle from which depot takes the order. Another very common one is split deliveries, which is an order may be so big you need more than one vehicle to do it. Like I ordered stuff from IKEA a couple of years ago, and it came in 2 separate days with two big vans. Um, and there's like many other variations where you change slight feature of the problem and you have a completely different flavor of it. There's plenty more, but these are the more common ones which I've seen. Um, yeah, how does it relate though to like the practice? So this is the textbook one. I believe you're probably familiar with it. What is the messy reality flavor? Now that may be when you get a request where a driver earns the same amount for each delivery, whether it takes 5 minutes or 45 minutes. Um, so what do drivers do? They may be sequencing the routes, like resequencing after you made the plan to hit all the easy stops first, because they know they can get it done over quickly, and then they can take their time with more complex ones. But this may create a problem if these more complex ones are paying more for these deliveries, and they want them, for example, to be done early. Um, but they still end up at the tail end of the routes. Like these are problems you may face in reality. Like there's the various ways you can solve this. You can change the process. You can be like, why don't we pay the drivers more? It's a valid solution. But for some reason that may not be possible as well. And then it becomes to like, how can you make this algorithm work for this kind of feature? You may have other things you'll be facing. Driver preferences. It could be that a driver really likes walking in the mornings or in the afternoons, or they know a certain area really well. So if they walk there, they can be really fast. But if you give them a new area, they're going to be slower. You don't necessarily have this in your data, or they may be certified to handle certain type of deliveries, so you can't just randomly assign it to random people. Or, traffic patterns. You can imagine, when you're building a data set, you're trying to solve this computationally complex problem. You have travel times and travel distances, but how do you take into account traffic patterns? Like you may know that at a certain time of day that's going to be congested, but you may not have the data for that. Or even if you do, how do you encode that? Um, Customer satisfaction. You may be dealing with customer time windows. Like in my case, we were doing grocery delivery, and the customer would check out with a preferred time slot when they want to receive the delivery. For example, 1 to 3. Is it a bad thing if you schedule delivery to be early? An hour too early may be not great because the customer may not be at home. 5 minutes too early may be acceptable. Similarly, is it bad if you're 5 minutes late? Maybe, maybe not. But if it's bad, if is it bad if you're half an hour late? Those things are never really black or white. Uncertainty is a very big, difficult problem to solve because you have uncertainty in everything. Uh, in your drive times, you're guesstimating. You may be using Google's most advanced models, but they're still estimations, and the reality can be different. Service time durations, like how much time do you spend expect the driver to spend at that place, uh, can be a difficult estimate, and there's a lot of variation. Like how do you account for that? Finally, you may not have the data you need to be able to encode the feature. How do you approximate, or how do you find ways to encode it? Ultimately, the reality is how do you translate these fuzzy requests or requirements into like formulations that do work, yeah, so today's workshop goals, I kind of like set up the workshop a bit in two ways in how I thought we could work. Um, but what I want to focus on is the left box is translating business requirements into mathematical expressions that you can implement and leverage to get the behavior you're looking for. Uh, to be able to do so, you need to be able to load a data set, run a data set, test, see the output of it. I tried to provide you for this by sharing the GitHub upfront, because you won't have time in the workshop to be able to do all of that, at least not in the time we have. So that was the motivation. So you can focus on the implementation and translation and test your ideas and get feedback, visual feedback at least. Now, if you have done so, you may have seen that I've used a solver called Timefold. And why I did that is because, first of all, I love that work. I've used a former version of Timefold called Optaplanner in my work. So a little bit of history. Timefold is an open source Java library that you based on meta heuristics, and you can use it to solve any type of optimization problem. Yeah, the thing has been in development for more than 15 years, and it was formerly under the Red Hat label. As Red Hat been bought over by IBM, I think they phased out product, I'm not sure, but the founding team members have like spin-off, forked a version of OptiPlanner and created their own open source library called Timefold, and then a startup around it. Look it up. The documentation, etc., is great. Um, and I was using it to like plan for 10, 15,000 deliveries a day, so it works. As I said, it's a Java library and runs on the JVM, and I think they also have or had an experimental Python API, which I've used in this work. Unfortunately, though, they seem to have stopped supporting that for practical reasons, but an open source alternative emerged under the name of Black Ops API. Look it up if you want to continue exploring this. And I kind of want to talk about a little bit how Timefold is set up, and if you have looked through the code, you might have seen that. It's a bit, it's more like software friendly and less like mathematical, like as compared to other solvers where you express everything in equations or a form of equations. It uses the concept of domain models, so you basically have your you formulate your problem in objects. For example, in this case, it will be vehicles, deliveries, locations, customers. That's your data foundation, and you encode your decision variable into that. In our case, it's like this task or this delivery gets assigned to which vehicle in which sequence. And then where the magic happens is really the constraints. You have all the freedom. You can use all the things that are available to you programmatically to implement those. That's what was really powerful. And as I've said, like I've built it around a web interface where you can actually visualize something. Because I've often find that when you're working on it, you get solver looks, etc., but they're not very informative. You want to be able to see the result of your work. Now, how does that look like in practice? And this, for example, is as a data class in Python, which is, I think, the one I wrote, is a vehicle. This expresses a vehicle. It has some features like ID, maybe a driver profile, location, capacity. Now, you may note that capacity is expressed as an integer. Think about whether that's a right or wrong expression, or there's a better way to express it, because this is already a problem, which is very interesting just to talk about that. But you can also encode functions. For example, if for this vehicle, you can encode a function that sums the total demand of the customers that are allocated to it, or the total distance traveled by the vehicle when the plan is out. And how does a constraint look like? It's quite neat, really. This is a more recent API development. It follows a very neat structure. You can tell the solver that for each entity, in this case a vehicle, do the following. Now, if that's more than 0 visits, compute the total distance and assign it to the soft score and give it a name. You can do more complex operations as well, but what does this mean? In Optaplanner, it solves the principle of hierarchical optimization, meaning you can express as many as you want hierarchies. It will always prioritize optimizing the first order, then the second order, then the third order, etc. And in this case, we're using hard, medium, soft, which is 3 layers. You have the primary is hard, the secondary is medium, the tertiary is soft. You also have hard, soft, and bendable. Bendable is you can have as many as you want, but you typically don't want that. And some of you have emailed me with your submissions and say, I don't know where to put it, which is a problem I do recognize. It's like often not clear whether an objective or whether a constraint is an objective, maybe a soft objective, maybe a hard objective. And where do you put it and how do you weigh it against others? That's something I'm hoping to touch upon later. So let me give you my mouse. Yeah, let me give you an example of how I kind of like thought about doing this. So, right. So you can run the repo with this command gradio interface.py, and that would spin up to work as a local host. And you should be able to let me just there we go. So, and that will give you this interface. At the same time, it will give you a bunch of logs. And what I wanted to show you is like how you can use this to work with. So I've coded all my active constraints in this list. And now I'm gonna run it without any of these. So with only these active. So we have the vehicle capacity constraint, the time window constraint, and minimize vehicle constraints. And if I trigger this, let me just change the data set. I've loaded like a bunch of open source data sets, which are not obviously real, but they're useful in just getting the idea across, I'm hoping. For example, this one has 50 customers, 25 vehicles. And I'm going to give it 15 seconds to solve. I'm gonna run this, and then you can go back to the logs. And you should be seeing what the solver is doing. Whenever you do this, it's really useful to learn how to read solver logs. I believe all of them have a form of them. So in this case, what is happening is it started to solve with this score, this 0, 0. It has two phases. It has a construction phase, which builds an initial solution, and then a optimization phase, which tries to optimize that. The solution it came up with was 12 vehicles active. So this is the hard constraint, meaning if you have a time window violation, it will show up here, but 0 means you don't have any. We're using 12 vehicles and 0 soft. And this is because I haven't activated any constraint that writes to the soft level. It starts with 12 vehicles, ends up with 11 vehicles in 15 seconds, and it has an average speed of 34,000 steps per second. This is important to note, and I'll tell you why. So this is the output. Now this is chaos. I don't think any driver or any planner would see this and be like, yeah, this is great. So, as a first pass, you may think, let me um, let me minimize total distance. And now you can see that's been picked up as a change, and Gradio seems to like shift back. I don't know why. But let's redo it again, like 15 seconds, same data set. And you'll see that this time we didn't have a 0 soft, and now we do have a value for that. This is the value of the soft score, the total distance. You may also have noticed, let me see. Yeah, so it starts off with 2,689, and with 12 vehicles, and it optimizes to 10 vehicles and 2,200. So it improved the initial solution it found, which is great. And it did so in 21,000 steps per second. Now you may notice that's less than 34,000 by roughly a third or so. Which is important with this type of solver, because the faster it can evaluate solutions, the faster it can navigate the set space. So us activating the computation for total distance has an impact on the performance, but that's acceptable. You always have some form of impact, and we can see that the solution is different, and I, you may want to argue that this is already a step forward, and I would agree. So that's like how I thought about how you can use this. I'm hoping you kind of like use this in something where you encode your own version and then you see what happens.
Hi,
Um,
Kerem.
yeah.
Yeah, we do have a question from chat. Francisco asks, do we have the mathematical formulation of the base model?
Not in the traditional sense, if that's what you mean. Um, I so in Timefold um, I do have the formulation where you minimize vehicles and minimize distance. So I have that's the basic formulation which is shared in the repo, if that's what you're asking. But it's not expressed in a mathematical way as you typically do with other solvers. Does that answer your question, Francisco? I've used Timefold Solver. Awesome. Yeah, if you have any more questions, feel free to ask. Right. So now I want to pass it to you, really. Now, suppose you had a first pass with the objective to minimize total distance. You have tested this with your in your business or with your stakeholders, and yeah, they seem to be not excited or happy about it, and you get some feedback. Now, in this case, a dispatcher tells you, our drivers keep complaining about their routes. They find that they're all over the place geographically, and manually, our scheduling team spends 3 hours adjusting these routes every day, because drivers call and saying this makes no sense. First I'm there, then I'm there, I'm zigzagging across town, and I'm losing precious time in traffic on and off highways. We need routes that are more compact, more geographically clustered. So drivers aren't driving past the same area multiple times. They can resequence the routes if they have to, but without having to go on and off main routes. This is something I actually faced in reality. So what I want you to do is break out in groups right now and discuss among yourselves. If you have implemented it, you can share that, like what your approach to this problem would be, like how would you encode it? How would you, is it a hard constraint or is it a medium constraint or a soft constraint? If it's any of those, how does it weigh against any other objective you may have? Discuss and think about like the pros of the approach, maybe the cons of the approach. Does it impact the solver speed? Is it easy to compute? Do you have the data? And then I'm hoping that in 20 minutes we reconvene here and then we can share it with a broader group. Okay, I think with 53 past, let's use the next, let me see, like 17 minutes to reconvene and share what you guys have thought about. Given the clusterness ask, what are your approaches or your ideas and how you can make this work? Anyone willing to share? Either speak up, you can write it up if you want to. I'll open the chat as well. And then I think before we continue, I'll share my approach to it as well. Anyone would love to speak up?
I mean, yeah, I can speak up.
Go for it.
We had basically three ways to solve it. The first approach was mentioning zones or clusters, like the clustering the approach first. So we just basically cluster the customers into cluster groups and then solve individual clusters and then rerun it. So we just have different clusters we can solve. So we also vary the clusters. The other approach would be to define the customers into zones and then say you can only allowed to visit, keep it as a global solution for all the customers, and then keep the just restrict the number of zones you can visit. Let's say a driver can only visit like let the zones be postal code whatever, and then so you can only visit like 3 areas within your route or like 3, 4. This could be a solution. And the other approach would be having like a centroid of the visits. Basically, with all the visits, and we have a centroid of the visits, and we want to minimize the distance between the centroid and each visit. And we could also, divide then the number of this by the length of the visits, so we don't penalize longer routes just because they're longer. Of course, the distance to the centroid will be longer. This could be another approach. Or to square this distance to kind of penalize route
longer deviations.
Yeah, exactly.
And what do you guys think of the trade-offs? So like what are potential problems or bottlenecks you may face with any of these? And what are maybe things that the solution is great at? Did you have the chance to discuss that?
What I noticed was that when creating or enabling the time window constraint, that everything falls apart. So the more reduced the time windows are and limited to the problem space a priori, I think that would give a better result. So if you know that you're going to cluster for a certain situation, you must also offer the customer the time windows that are still available in that zone. And if you have a random set of time windows, then you cannot really optimize for that unless you let that restriction go in a certain direction.
Yeah, I love that observation because that's also what I have observed myself when I was working on this. And you're right, like if enabling, disabling time windows has such a big impact on like how clean those clusters are, and being able to relax them in some form can help you improve your solution. by a lot. The question, of course, becomes like how much leeway do you have to relax them? For example, where I was working, we had time windows of 2 hours, and it was grocery deliveries, and I was also a customer myself, and then I was pissed that if I've selected 12 to 2 and they didn't show up or they were too early, I was pissed because I wasn't maybe not home yet. I'm gonna miss my delivery, or I need to leave, and where's my delivery? There's always leeway, like but how would you encode that?
I think the other option would be as a true possibility is if I do not constrain the cost of the driver. So the driver itself is has a zero cost, and I would say you are just assigned to this zone and figure it out yourself. You don't have to be done as fast or something like that. Then the locality becomes only that zone, and then you can do something around it. But I did not really find where the minimization of being done as quickly as possible or something is modeled in.
I would have a question about that. Is how would you define zones? Because that I think intuitively makes sense, but with data, if you work in urban deliveries, there are ways to express zones. It could be a neighborhood. Each country, each city has their own way of expressing. You could copy that, but that may not necessarily work for each other's situation because your deliveries may not. They may, you may have a few deliveries here and a few deliveries there. You don't want to be too restrictive on the zones. And a way to do that would maybe express the minimization of how many zones they visit. That could be a valid approach. I think that's one of the things you mentioned, right, Dominic?
Exactly.
Maybe I have a comment on the approach. Maybe they said that, for example, anything that we do beforehand, the optimization like clustering, dividing into zones, or playing with the time windows and etc. It has an effect, and that effect might not be, as expected. For example, dividing it into clusters, it's by itself another optimization problem. VRP itself is a clustering problem. Clustering and scheduling combined together. So inside the same algorithm, we need to do both of them. If you split into two parts and then solve the two problems separately, you will lose optimality. Even sometimes you can lose feasibility. So I don't think that it's a good idea to cluster first. For this compactness problem, for example, one of my options is what you already have in the code, actually, minimization of the total distance. In fact, indirectly provides compact schedules. So when you try to minimize total distance covered, we expect that the drivers cover less distance. Another approach can be this. Instead of minimizing the total distance, we try to minimize the distance covered by each vehicle to the depot, so that each driver has a minimum possible, let's say, driving distance, so that it's compact. So we are not adjusting other constraints. We are just adding a new, let's say, objective or a soft constraint. So
Agreed.
these are my idea. Yeah.
I think those are
same
valid
thing that
ideas.
we did discuss as well, because if we are adding the clustering approach, so it will be going to be suboptimal solution, because we are going to solve the cluster separately and it will no more going to be global solution. Okay, but maybe what we can do here, so just solve the solution, solve the problem entirely considering all the constraints and variable, identify the total minimum cost is required, okay, to cover all this, and then solve secondly for the reducing total number of a distance. And while considering the distance, okay, so that the driver should not cover the entire city, so for that, okay, if it is required to cover the fulfill the demand, okay, we don't have any options, okay, they need to cover that, okay. But providing the suboptimal solution, while to just minimize the total distance they are going to be covered, so we can add the one more related to distance, which is coming back to the depot. Okay, if we add that, okay, so that will be going to be reduce the total distance they need to be traveled. Okay, and even in that case, if drivers do maybe something like as we do most of the times, that if the drivers are making any changes in the plan, how that plan is reducing the global optimal. Okay, what is that percentage? And if we consider that is a soft constraint, okay, so 20%, 30%, whatever that may be, up to that we can just again solve for the reducing the total distance.
Uh, I love the inputs. Thank you. There's a lot to unpack. But yeah, I think maybe I'll try to start with you, Hakan. You're right. If you fix the number of constraints, if you optimize for that first, and you try to like restrict the problem such that the routes are within those clusters, it's gonna most likely be suboptimal in some form, and that may be okay if it achieves what you're looking for. And yes, I think there's also other ways in which you can actually, I believe, very common heuristics to solve VRP problem are grouped into cluster first, sequence second kind of structure. So there's also other approaches. Yeah, no, I agree with your observations. And minimize total distance works to some extent, but I don't, in my experience, it didn't achieve what our dispatchers were looking for. So I had to find different ways to do so. I think you mentioned a lot. I'm not sure if I'm gonna be able to remember every detail. But yeah, there's, like you say, there's also ways to pass the clusters as like extra data to the optimization model and try to minimize you penalize the amount of deviating from that, but you don't overly constrain the problem. That could be a valid way. I think, Dominic, you also mentioned one of your approaches was to the compute the geographical center of a cluster and minimize the squared distance to that cluster for each customer. And I love that idea, and it's also one of the ideas I had personally tried. Actually, that's maybe what I want to kind of like go to next. Is this is a way I had implemented it to basically compute the center of the coordinates in our case, the x and the y, and then you take the Euclidean distance, the squared distance without the root, and you try to minimize that. And I was able to plot the change. Like this is with distances, this one is with clusters, and as you can tell, geographically speaking, when they're departing and returning to the depot, everything seems to be a bit more neater in this very simple data set. Which, in my experience, this was a good first pass. I believe Dominic, you also mentioned being able to normalize it by dividing over the length of the route, which is fine. But when I was working on this, I found that the differences between we basically compute the average distance for each customer becomes marginal and became very hard for the solver to navigate a search space. So I had preferred to without the normalization, but then that worked to some extent. Dominic, sorry, Stefan.
When you're trying to do this, is there a reason that you can just do this in a Euclidean space, as in straight line, as the crow flies, etc., and do not need the actual distances? For example, if you have a street network, then it is never the way that distance, basically.
Correct. Yeah, so in this problem, we only have Euclidean coordinates, but in reality, I'm hoping you have richer data. And I tried both. Like if I tried doing Euclidean distance on real map data, and you find that visually speaking, if you look at a map, you see everything becomes really clustered. But that wouldn't make sense because you may have a river and you need to drive around it. Well, as a crow flies, that's close by, but in practice, like there could be a whole peninsula in between, no? So using drive times or drive distances are definitely more realistic and would be recommended over using something like leading distance. Any other questions or thoughts on this?
Yeah, just a quick remark. Would you mind scrolling up a few clicks so I can see the code? Okay. So in this function is then used in a constraint, right?
Correct.
Yeah,
Yeah,
and then if we would like use not geographical Euclidean distances, but real routes, then we would have like a very expensive evaluation time, right?
100%. Good observation. Yeah,
So it may not be feasible.
Correct. At least computing the centroid of let longs is going to be computationally way more expensive, and may also be a bit nonsensical. You maybe you center maybe like a body of water or something. I don't know. What I had used to simplify that, for example, would be use the first customer's location and try to be geographically close to the first customer. And hereby, I thought about ignoring the distance to the first customer because I reasoned and I'm motivated that the driver doesn't care that they need to drive an hour to get to the area, but they don't want, once they're there, they don't want to get on the highway again and go another half an hour or an hour to the next spot. They just want to do all the the deliveries in the next so many hours they're working and then be done and over with. So if it's contained within an area neighborhood where you don't hit the main road, you can just take, in between routes, they're going to be fast because they can manage risk much better. And I find that to be working better if you ignore the to and from depot distance. You don't penalize the solver for having the first customer being very far. It has more flexibility. And a way to express the center would be maybe use the first customer as a proxy.
How much better is the hand optimization if you do it by hand then?
Sorry, how much what?
Is there an option that your hand optimization where you would drag the route in a certain direction would be actually a better route, or is the optimizer actually correct by this is the optimal route, but just not understandable?
Good question. Depends. It depends how confident you have. When you model it, like you make assumptions about the trade-offs between various objectives. Like we're talking about one objective over here, but you may have like 3 or 4 more objectives which we haven't touched upon yet, and they all maybe make more sense as soft constraint. Now, when you add this, like how are you gonna weigh this against your other terms? If you have a summation, the units may be different, and it'd be great if someone can tell you this one is one of this equals 2 of that, but that will never happen. So you'll need to make like an educated guess of how that's going to look like. And ultimately depends on how much you trust that. It can be mathematically optimal, but still be garbage in reality. And your job is to convince the users that this is a good solution. So I find it's not super useful to be just focusing on your objective term, which is informative to you about like where you are in your search space, how good the solver performed. But that ultimately depends on how well you were able to translate the model into the formulation. So I was still focused on other metrics that you evaluate your solution on, and like if you have those.
I have a small question, please.
Sorry.
About my name is Aslan. I'm very expert. I developed this algorithm myself. So my approach was time resource so the RPs, but I don't know because I don't use Timefold or stuff like that. So what approach they are adopting?
I don't think I've been able to understand you because your voice keeps dropping. Maybe can you write it up?
Sorry?
I wasn't able to follow on because it was not audible. Like your voice was very low. The volume was very low.
Do you hear me better now?
Can you repeat it?
Do you hear me better now? Can
Yes.
speak up here. I mean, I don't use the time folder of that level. I'm just questioning about the approach. Is it root first, cluster second, or the other approach with cluster first sequencing them?
Are you asking if it's a brute force approach or cluster first and optimize second?
Cluster second or the other is adopted by Timefold. And if you have any idea what's the difference?
Sorry, you're still dropping, but I'm gonna go with what I understood. It's not brute force. Timefold uses meta heuristics, which is a class of algorithms, and it has like I think 6 or so algorithms it uses. Those are based on well-researched heuristic like logics that is implemented in this case Timefold, that employ certain strategies to navigate the search space. I think brute force is one of them, but I mean if you're using this library you would not opt for that. But it has like class of algorithms that you can switch and try and optimize, see which one is best. You can benchmark them. It's really powerful in that sense.
Kerem, we do have one question
Yeah, sure.
from Harald. So he asks, minimizing clusters or minimizing distance both do not take into account some allowing over capacity, right? So you can
100%.
see the chat.
Yeah, I can see it. 100%. No, it doesn't. In this formulation, as I've shared it, capacity is expressed as a hard constraint. Technically, you should not be able to go over it. The optimize would ensure that. Sidestep, though, I've expressed it as an integer in this data set as an integer. In reality, it's not. If you think about deliveries, there's 3 dimensions, and they may not all be neat boxes. You can't necessarily use the entire cubic meter space of a truck neatly to like you can't fill it 100%. There's going to be air gaps. You may have odd pieces that are long in one direction and small in another. It's a problem on its own to be able to find a way to express this volume or the size of the deliveries you're doing. But yeah, that's a slightly different topic. With that, though, I want to move on to the next topic if there's no more questions.
Can I jump in and ask a kind of a stupid question?
Sure.
Okay. How about add another objective using the longest distance. How should I phrase it right? Okay, say you have another objective that is equal to the largest segment in all your routes. That will kind of minimize the distance between stops, right?
So you're saying if you try to minimize the largest segments of any route,
yeah, right,
you'll have more compact routes.
Right. Then now the drivers are complaining that they are going from the one part of town to another part of the town, right?
Mm-hmm.
Yeah. How about that? How about that as part of the objective?
I don't know if I tried that. Good idea. I think though what will happen is that deliveries will not necessarily end up being clustered, but may have like a more of a long shape, elongated shape. If you think about plotting them and drawing a line.
Right. So like will just keep going and maybe further away from the depot or something.
Yeah. So the trick is the motivation, the real story behind this thing, right? This requirement, this ask, is that drivers prefer to have control over in which sequence they can do the deliveries if needed. Your route may be the most optimal when you hand it over to them, but maybe there's a sudden traffic congestion. Maybe the delivery person wasn't at home. They may know the area way better than you do, and they have their own preferred way of going around it. So they will resequence if they have the freedom to do so. if all the customers are geographically clustered, it's easy for them to resequence because they're still going to be covering the same area. If they have to go through areas, because it may be like segments may be short, but if you add them to each other, the distance between the first and the last may be much forward. They don't have a lot of flexibility in sequencing.
Okay.
So
So
that's probably
I
something
guess
you'll probably run into.
Okay, I guess in that case, well, if you can do that, you can ask every driver to propose a matrix. Like if you are at vertex A and there are vertex B, C, D, which one you would like to go next? And once you have this kind of matrix, then you can kind of use it as an objective, another objective. In a way.
Potentially. Those are ideas you will worth exploring, really. But yeah, I think
Okay.
I'll move on to the next task then, because don't want to.
I'm sorry for the delay.
No worries. Keep them coming. So for the next task, I'm hoping you've had a chance to think about this as well. Slightly different. That builds upon that. In this story, that we have premium deliveries and we have regular deliveries, and the premium deliveries take much longer for the driver to perform. But for the drivers, they get paid the same, whether it's a regular delivery or a premium delivery. And in this story, the business has lost 3 drivers when they went to work elsewhere because they keep having these premium deliveries and they're not happy about it because they're earning, it affects their earnings. They want to be able to take the easier ones because they can do more of them. Now,
Kerem, I do not see the screen if you are saying the presentation.
Is everyone else sharing the screen?
I can see your screen clearly.
No,
I can see it.
why am I not able to see?
Well, if you don't, please holla or write. I'm hoping you can.
Yeah, I think Bridget, it might be just you. Yeah.
Right. Cool. Yeah, so again, same setup. Think about how you would make this fairer, right? Like how can we keep the drivers happy? Of course, you could argue why don't we pay them more, and that's a very valid suggestion. Please do that if you ever encounter this problem in reality. You cannot see the screen as well. Okay, let me reshare. But honestly, actually, I don't think it really matters. I'll copy this. I'll copy the text into the chat and then send you to breakout rooms. Yeah, does anyone want to share like what they thought about it as an approach? I've heard some nice ideas.
If no one has, if you don't mind me starting, we had an idea of having a range of number of premium locations to be assigned to a driver and minimize the deviation from that range. That was the general idea in our break room.
Yeah, I like that. That makes a lot of sense. I think you also had a counterpoint to that if you introduce that, how does that?
Adam had one, and I'm actually really curious on how you would solve it. It is if the premium spots are not distributed evenly, but are more like collected in one spot and close by, it kind of makes it really difficult because it challenges distance and premium spot deviation. And so we didn't really know how to attack that problem.
No, I think that's a very good observation. Let me think about it as well. But yeah, I think this kind of like, I hope everyone understood it. Like the idea is basically if you have all the premium ones are in one part of the town and everything else is elsewhere, and you need to distribute this, you need everyone going there, and that may like be at odds with the first constraint where we're trying to cluster everything. Like how do you make this work, right? My short answer is I don't think I know. But this is also what you would probably face in reality. You will have some sort of ask that is at odds with another ask. And question is, how do you treat the trade-off between the two contradicting statements or objectives in this case? I think one of the suggestions was to be able to maybe just have it such that you group these routes together such that they're clustered, but you try to get buy-in from your stakeholders, the drivers, etc. That yes, today they may have all the bad deliveries, but over time they'll make sure the earnings is within the acceptable range for every other driver, and that's a very valid approach, I would say. This kind of shows that you also need to not think in your own silo, like how can I express this in a way that's always going to make sense, but like how can you change the process? How can you involve other stakeholders and get their opinion and eventually buy in? Because those are things you'll face as well, because they need to be executing your plan or the output of your model. That could be a very valid approach, and I would say that's good thinking. Any other thoughts, comments, questions? I know it can be a bit awkward, but feel free to speak up or write up.
Dominic has very good ideas.
Yeah, so I just did a non-linear increasing or superlinear increasing penalty for every premium delivery, which will lead automatically to a distribution without knowing anything in advance. But I primarily did this because I'm not fully understanding the interface of Timefold and just having like a squared penalty of the number of premium deliveries. So, I mean, the L1, L2 metric automatically penalizes like deviations from the mean. So you don't know how many deliveries the others have, but since the penalty increases with every further, or increase superlinear with every further premium delivery, you automatically get some balancing. But with nonlinear penalties, they can get a pain to balance with the other constraints or objectives. So that's definitely something to look out for. What I would have preferred would be to have some target of premium deliveries for every driver and just penalize if you go above this target. But I didn't know like how to implement this with Timefold.
Right. So I think I like it. It's I think similar to the other suggestion as well in ways, but you're saying that you kind of like try to express the number of deliveries in a squad form each route such that they get distributed as evenly as kind of as fairly as possible, I'd say. And I think that's a valid approach. That's definitely what one of the examples in Timefold documentation is suggested for like fairness, which is also very common in practice. Yeah, and then you kind of touch upon what's the challenge with it as well is you have this expression that may be squared count of number of premium deliveries in a route, which is fine. But how do you express this against the other objective? You could introduce like hierarchical objective where you have like maybe this is a soft score and you if you have a softer score they didn't call it that but let's just call it that that it will always try to prioritize clusters, but within those clusters it will try to find a solution that's fairly distributed that may be good enough, but that may also be such that it never really cares about the fairness because there's always going to be a solution that's better clustering wise or distance wise, but it's going to yield uneven assignments. Then you need to level it up and have it on the same level. Then you get to the point like how do I weigh this, right? Because you're counting a squared value versus distance, which are very different units. How are you going to weigh them against each other? And yeah, I think this is kind of like where I was really going with these two tasks, is that in practice, I always say like optimization is part art, part science. Like the science is how do we solve it mathematically? What sort of algorithm use? What smart tricks they use numerically, computationally. The art part is how do you express this? And I don't think there's a right or wrong answer. You just have to figure it out in ways that makes sense on paper and in practice. But by that I mean, what I would do is work with examples like what I did in the demo. You have this few data sets. You see how your implementation results in those data sets. You show them to your stakeholders. You can see if they like it. And then once you do that, that's fine. That's like you optimizing over a few data sets, like machine learning terms, you're overfitting to a certain degree. And then you want to be able to test this at a larger scale if you have the infrastructure to do so. You want to be able to run this at as many reasonably data sets you can get and test out how that would look like when you call metrics. But like the guesswork of the coefficients of each is a bit of like, yeah, it's guesswork. It's like whatever you think it makes sense. If you can make this visible to the customer, like I think you'll make it so much more transparent to them that if you have a UI or whatever where they can slide importance or like how important a certain thing is in term is in the objective, they can understand how it works. If it's black box and this one is 1.5 and that one is 7T and that's coded but like it's not surfaced, that can be a very much black box to the end user. And the trick is finding ways to make them understand how the things work, you know? We have like 30 more minutes left. Kind of don't want to take up too much time discussing this and kind of like close up and towards the questions, if that's all right. Yeah, like I said, I did have a third task. I'm gonna mention it. We don't have to discuss this, but this is like also what you see a lot in reality, is that you know, in the story, the late delivery rate has jumped from 12 to 28%. That their KPI is to be under 15%. They don't like where we are currently with planning. We're constantly delivering late. We're using an average service time of 5 minutes and some GPS drive times, but you know, this doesn't seem to be good enough because people are late more often than we like. At downtown deliveries may be an average 12 minutes, and residential vary between 3 to 15 minutes. But we observe that drive times are longer than GP estimates due to traffic, etc., etc. We want to get back under 15%. How can we do this? So it's a lot of information, but ultimately what I'm trying to convey here is that when you're solving a deterministic optimization problem, in reality, there's a lot of uncertainty. In your drive times, they're estimates, they're never accurate. Your service time or estimates, they're never accurate. But how would you encode the uncertainty into your model? If you take the service time, maybe using a machine learning model to predict the service time given the characteristics of the delivery, which is fine. It's still a point estimate though. Like in reality, it's going to be more or less than that. How would you ensure that you can handle, you know, variance to a certain degree in your plan? That's really, whether it's vehicle routing problem or you're doing any other optimization problem in practice, I think that's a very important aspect to think about your plan. How would operations handle uncertainty, and how can I find a way to bring that into my problem? Don't want to discuss this, but I'm open to questions about this in a minute. So yeah, I think to round up, right, what I wanted to get across is that practice is not clean, it's ambiguous. Like, you know, you don't have a nicely formulated object, like a problem with this objective, these are your constraints to find the best optimal solution. It's never going to happen. You're in charge of defining the model, and you have the flexibility to choose what you want, express it however you want, really. I'm also like believer of there's no right or wrong answer. Sure, some approaches may be better than others, but it's all about trade-offs. For example, you may have a very fine, like, precise way of defining clusters that work great, but you slow down your solver to a halt because the computation is very expensive. Great, but is it practical? You need to find a more approximate solution that's going to be fast enough for the solver to converge and still yield the results you're looking for. So it's ultimately about trade-offs. And then finally, you want to keep testing your idea on both qualitatively and quantitatively. Qualitatively meaning you'll be looking at the solution like how we did in the demo, right? You encode something, you see what happens. Quantitatively, which is great, like you can do that over a few data sets, 4 or 5, maybe 10, but you won't be able to do that at scale as a person. And in machine learning terms or data science terms, you'll be overfitting to a few data sets because those data sets have certain characteristics that may need to be present in other data sets. So do that, but also think about the bigger picture and how would this look like in terms of your metrics if you have those. And for that, you need to be able to test at scale and run them in parallel for a while, aggregate the statistics. Yeah, and with that, I wanted to ask you, maybe think about what round challenge you're thinking the most, why. Maybe you had an assumption and you would question that. And this is something I see a lot, like how would you approach a stakeholder who insists, all requirements are critical? They may express a preference and they may express business, like a physical constraint, for example, the capacities of a vehicle are physical constraints, but a driver will have a preference to drive a certain way or put things in a specific order into the truck. That's also something that happens. How would you treat this when you ask them which is important? They'll be like, that's important too, that's important too, but you can't get out of them which one is more important to what degree. And maybe next time you're solving an optimization problem, what would you do differently? Don't have to answer this, just think about it. But and with that, I kind of want to thank you and open the floor for questions, feedback, what worked great, what didn't. And also, yeah, thank you for sitting with me for 2 hours.
Kerem, we do have a question.
Yes.
On the chat.
What I mostly wonder about, what is a way, things keep jumping. What is a way to get more variance of a potential solution? Stefan, may I ask what your motivation is for the question?
So we know that every time that the solver comes with a solution, it might not be deterministic because it's the time that it takes to resolve it. If we limit the time, it comes with another result. And if we give it more time, it comes with another result. And it might not even be the same result if you run it twice. But if he would like to see another result, is there another way to say, give me the next best result? To present somebody's solution, I can do it better. This is another variant, but it has the same score. And that we can then evaluate why we think that one or the other one is better, and therefore add more constraints to get the other one a more preferred way later.
I love the question. I think that's also a good way to think about it. I think, yeah, you can have solutions that are objectively, objective terms the same, but qualitatively they can have very different characteristics, and they may be better in one way or the other. I think it really depends on the solver whether you can surface this, but it's a very good way to think about it. I know that Gurobi has something called the solution pool, which stores, I think, solutions. I don't know exactly how it works, but you can surface to the user. This can be a way to give the user more control about what solution they pick. Like, you don't serve a single plan, but you give them a few to choose from, and they can be better in one way or the other. And if you can choose smartly, that'd be great. I actually did this at Kerem when I was working there, and our motivation was, it was like there were so many contradicting objectives that we couldn't make a single choice. We didn't want to squash it down to a summation of them really. We did that, but we also keep track of solutions that were better in some of those terms and surface them like in a table format with some characteristics and let them choose. They could click that. That's one way to do that. For Timefold, I don't know if that's possible actually. Maybe it's a feature request, but it's a very nice way to think about it. Hope that answers at least what you asked. What are the best open source solvers for complex models which can be further implemented on a large real data set too? That is a good question. I don't have experience with all the open source solvers, so my answer would be biased towards a few. Like in this case, I have used Timefold. I think it's an excellent open source library because it can scale really well based on the fact that it runs on meta heuristics, which tend to be like they scale really well. I've also used OR tools for VRP, which is also like maybe easier to set up, at least from a coding perspective. And it works really well, and it also scales reasonably well, but it hits a limit faster than I think it hits a limit faster than Optoplanar when I was testing it, but don't quote me on that. And that I found, for example, what was limiting with OR tools was that I could get 80% of the features in, but I had some like specific like this clustering thing I couldn't get in the OR tools at the time, or it was very difficult to do so at least. Have you used OR tools? If so, what your thoughts? Oh yeah, that's apparently answer that question. How big of VRP's Timefold can tackle? Can it solve like 1,000 nodes, 10 of vehicles with time windows and capacity? It can. So I use it to optimize 10 to 15,000 deliveries. Excuse me. 10 to 15,000 deliveries. And the way we did it was partitioned, this was in Singapore, partitioned into like 6 areas, if I'm not wrong. And each of those would have overtime in the day. If you split it also into, we had shifts, the concept of shifts, like drivers would go around in 3 hours, come back and do that a couple of times. So you could deconstruct the problem in subsets, and then each subset was I think up to 1,000 nodes, and we could run it in 10 minutes or something. It would have quite good results. OR tools something similar. I think around 1,000 nodes start hitting limits and need to find ways to solve it better. I've used Hexely as a commercial solver, not for a VRP, but based on their blogs and benchmarks, they seem to be outperforming both of them by spade. Yeah. And there may be other solvers I'm unfamiliar with. Any tips for handling uncertainty in solvers like Timefold, the classic approach using some time buffers for redundancy, or can we incorporate a probabilistic approach with uncertainty quantification somehow? Excellent thinking. I think I can do both. Timefold this is why I like it. It's quite flexible in that sense. A way to do that would be indeed express like an objective that's slack, and maybe you try to minimize the slack while maximizing or minimizing other terms. Not exactly, don't have it quite ready on how you would express that. But there's a trade-off to be made between slacks and productivity. If you want to get more complex and you want to do a probabilistic approach, maybe you're able to have like statistics on it. Maybe you have the average time it takes to perform delivery, but you also have another statistic like the 80th percent quantile, 90% quantile, and you can encode. You can use those terms in your objective term in some form. With maybe you optimize for the average, but you penalize to some extent the 80th or the 90th quantile you're using. That could be an approach. Potentially other ways as well. What I mostly wonder about, what is a way to get more variance of I think I jumped. Sorry, my chat's jumping. Why to learn that if TMS can do it? Don't think I understand the question.
TMS, I think Christopher is helping them.
A transport management system, yeah, I mean, I know what it is, but we're not talking about transport management system. That's like under the hood, that's kind of like what it's using. if I get your point right. So in this case, you could be the one manager, you could be an engineer or a developer on the transport management system, and you're building features out that can support these kind of things. I'm hoping that answers that question. Are there any more questions I glossed over? What are the best open source solvers for network design and routing optimization problems? For routing, I might have a scale of 1K trucks going to 1K steps on a weekly basis. Again, I'm biased. I would start with Timefold because the examples are very clear. You can also try our tools. They have also very clear examples, but you may hit like a block or a threshold faster. That said, if you have like a large or like a middle size to larger size problem, you also may want to think about how you can break it up. Don't really know your domain, etc. But like, usually, like the smaller you can make the problem without sacrificing global optimality, the better performance you're gonna get. So with that said, I think we hit 6 o'clock. I all want to thank you all for sitting with me for 2 hours and for those that took the time to send in your assignments. I have seen them all. I may have not responded to it yet, but I'll try if I haven't. But thank you for taking the effort for that. And I hope it was, you learned a thing or two. And it was a bit experimental. I jumped around rooms and some were super quiet and some were very productive. Maybe it wasn't the best setup, but I hope it was still a success.
Yeah, thank you so much, Kerem, for doing this workshop. Obviously, there were some technicalities that we need to focus on for the next session, for the breakout rooms especially, that we might need to optimize it and maybe like lower the number of the rooms. So thank you everyone for joining and for staying until 2 hours. Sorry, I hear you go. So for the next session, we have, so this one was for the Kerem. This one was for Kerem. And then for the next, we have Carlos Zetina presenting training optimization models, like how to use machine learning to train optimization models. And then it's on November 6th. And then we have another one at December 3rd, I believe. Yeah, December 3rd by Christopher Garcia. And then we'll post it about this on the LinkedIn and send an email as well. So if you want more information about this, you can scan this link and go there. I think Christina might want to talk now. Christina, are you there?
Yes, hi everybody. Just to say hi.
Yeah.
Thanks for joining. I'm here with my kids, cooking dinner and managing kids. But okay, I hope it was a good session. Seems like the problems were quite interesting. So yeah, thanks for joining. Great to see you. And I guess we'll see you at the next events that we have.